So this question is asking us to use the triangle above, using equations needed on the coordinate plane, calculate the distance of point J from MK. So that means I have to look at this guy and find how far away he is from this segment. But to do that, I need a distance formula. And to use a distance formula, I need some kind of a point that lives here on this line, or this line segment. To do that, I need to find the line that's perpendicular. When I find the equation of that line, then I could find the intersection of this point and figure out the distance between this guy and this point on this line. So I need two equations. To do that, well, let me do the easy one first. Let's get the equation of MK. To do the equation of MK, we need two things. We need a point, let's use M, or we could have used K as well, and we need a slope. Now to get the slope of MK, we need the change in Y over change in X. And it's kind of calculated already for us. Okay, if we're going in this direction, actually change in Y would be this, so it would be -3. And going in this direction, the same direction, it's going to be 9. So this reduces to -1/3. All right, so I'm going to use point slope. So I'm going to take Y minus -3 is +3, which is equal to the product of the slope times the difference of X and the first point, so X minus 1. And I know I'm going to need to solve set equations equal to each other. So what I'm going to do is I'll just subtract 3 from both sides, and I'll get this result. Okay, now the next thing I need is the equation of a line that goes through this point, J, and is perpendicular to MK. So that means I do need the slope of MK. Slope of MK is equal to -1/3, and then the perpendicular slope of MK is equal to 3. So using that, I'll get Y minus 5 is equal to 3 times the difference of X and the X coordinate of J. All right, and I do know I have to set equations equal to each other, so I'm going to add 5 to both sides. And I'll get Y is equal to the product of 3 and the difference of X and 8, and add 5 to that. So what I want to do is, if I want to find where these lines intersect here, I have to set these equations equal to each other. So I'll get -1/3 X minus 1 minus 3 is equal to 3 times the difference of X minus 8, and add 5 to that. But to be honest with you, you're allowed to use a calculator, so why not use that to calculate it for you? Make you a lot less work. So let me just get my calculator out. Okay, and I'm going to graph these lines, right? This is my first line, -1/3. This part looks pretty much like this equation right here. And this guy looks like this equation. So what I'm going to do is graph them. And I'm going to let the calculator find where they intersect right here. So I'm going to hit second, calc. And number 5 says intersect. So it's going to find the intersect for me. And it's going to ask me, is this the first curve? Yeah, it is. And then there's a little blinking thing right here. And it's asking me, is this the second curve? Yeah, it is. Do you want me to guess? That's what the calculator is asking. I'm going to say sure. But the calculator is actually going to figure it out. And the intersection of that point is 4.9 and -4.3. So if I were to graph the altitude, right, it would start at J, and have a slope going this way, And now I know exactly where this point is. This point right here is 4.9, comma, negative 4.3. So, to find the distance from J to the line MK, I have to find the difference, the change in x and the change in y, to use the distance formula. So J is at 8, comma 5. And I want to find the difference, the change in y and the change in x. So to do that, from here to here, right, my change in y is equal to negative 4.3 minus 5, which is negative 9.3. And going in this direction, the change in x is equal to 4.9 minus 8, which is going to be negative 3.1. All right, so what's my distance? Well, the distance from J to K is going to be the change in x squared plus the change in y squared, and I square root that. So my change in x is negative 3.1 squared, and my change in y is negative 9.3. I'm going to square that. Now, when I plug into the calculator, I don't want to make things more complicated for myself. So I know that negative 3 squared is the same thing as 3 squared, or negative 3.1 squared is the same thing as 3.1 squared. So I'm going to keep it simple and just square 3.1. And I'm going to add the square of 9.3. And I will get 96.1 units. So, to answer the question, the distance of point J to the segment MK is 96.1, square root of that, units away. And if you want to find out where it's approximately, it's approximately 9.803060747. All right, now what we're going to do is going to continue on to question number 5, because they're connected, 4 and 5. And it says, find, using the triangle above again, find the length of MK. Now, MK, right, the work's already done for us. Because to find the distance of MK, it's really the change in x squared plus the change in y squared. Well, if I start at M and I go to K, I got to go down 3 and over 9. And when I do the work, it will become 90, square root of 90. So the length of MK is the square root of 90, which is also approximately 9.486832981. All right, the next part of this question is asking, using your answers from 4 and 5, calculate the area of triangle MKJ above. Okay, well, the way you guys first learned how to do area of a triangle is you multiply the base, the length of the base, and the height, and you divide by 2. Well, the base in this case is actually the square root of 90, and the height of this triangle is the square root of 96.1. So we multiply these guys together and divide by 2. Another way of doing it is also just multiply them initially and then take the square root of them. Let me plug it into the calculator. So I'm going to take the square root of 90, multiply that by the square root of 96.1. I'm going to divide that by 2, and I'm going to get 46.5 units squared, the same answer as we got above. Now, there's one other quick thing I do want to do with you. Over here, we have the equations set to each other, and we use the calculator to graph it, but if you really want to see how it's done algebraically, we'll do it here on the side, so you have that as well. So, I have this guy. Now, the first thing is, I got a 1/3 here. I want to get rid of that fraction, so I want to multiply everything by 3. And so when I distribute, negative 1/3 times 3 is going to really be negative 1. And then this guy over here will be negative 9. Another negative, a 9, x minus 8. And the last, plus 15. All right. Distribute over here. I get negative x plus 1 minus 9, which reduces to negative x minus 8. Here this becomes 9x minus 72 plus 15. Negative 72 plus 15. That gives me minus 57. So what I'll do is I'll add x and add 57 to both sides. And I will get 49 equals 10x. And so x becomes 4.9, exactly like we had earlier. Now, I need to find, this is the x value. So if I plug in x as 4.9 into both equations, I'll get the same y value. And I still need to get the y. So I'm going to plug it into the equation that's easier to work with. And the easier equation to work with was the one without the fraction, this guy right here. So I'm going to plug it in. So I'll put for x 4.9. And I'll let the calculator do the work for me. 3 times 4.9 minus 8, like the difference of that. And I'll add 5 to that. And I will get y equals negative 4.3. So the coordinates of the intersection point are exactly what we had when we let the calculator do the work. Okay? Hope this helped. Have a great day.